Now, in this section 2, we will be discussing the slope of an isoquant, which is called MRTS, or the marginal rate of technical substitution. Similar to the indifference curve for the consumer, the slope of the indifference curve is the marginal rate of substitution, right? And we know that this MRS is equal to negative MUX over MUY, right? Similar to isoquant, this, instead of MRS, we call this MRTS, or marginal rate of technical substitution, which is negative MPL, marginal product to labor, over MPK, the marginal product to capital. And it is just, in a nutshell, a summary of, the slope of isoquant when compared to the slope of indifference curve. When we want to find the slope of an isoquant, we are asking the question, right? Slope of isoquant. To find the slope of isoquant, that means that we are fixing the output, right? To find the slope, moving from this point to that point, to find the slope here, it is on the same, in the same isoquant. That means that this point and this point have to be yielding the same amount of output. If I change L by a bit, how much does K have to change in order to remain on the curve, or in order to produce the same amount of output, right? If I change L a bit, right, increase L a bit, how much does K have to change? So that is slope. How much K need to change so that I still can produce same amount of output, or remain on the same curve. So we have the production function, or the output has to be constant. It means that the change in L multiplied by the marginal product to labor, the change in Y due to the change in L, right? So this, the first term, means how much the output changes when 1 unit of labor change, that is MPL, right? How much the output change, how much the total output changes when we change 1 unit of labor input. If we change 10 units of labor input, then that would be the total change in Y due to the change in 10 units of labor input, right? So this is the change for 1 unit of labor. This is the change in total output. So we want to say, okay, but if L changes by, A unit of labor, then the total change of the change in the total product of these A units of labor would be equal to this. And this is going to be a similar interpretation. It's a total change in the output due to the change in this amount of K inputs, right? Multiplied by this is going to be the MPK, the marginal product to capital, or the amount of total product changes when 1 unit of capital change. We multiply by the total change in the capital, we get the total change in Y due to the change in the capital. You add these two together, it should sum up equal to 1, because the total change of the output has to be 0, right? Because of the same isoquant, so there would be no change in the total output. This one, this term plus this term has to be 0. So one has to be positive number, another one has to be a negative number, and vice versa. Okay, so based on this equation, You get this, right? And then we move things around and we have the change in K is equal to negative MPL over MPK multiplied by change of L. Now this is the slope of the isoquant, right? Rise over run, the change on the vertical axis over the change on the horizontal axis is the slope, right? So the slope is just equal to negative MPL over MPK, right? Or if you have a production function, this one is just the derivative, the first order derivative of the production function with respect to L or MPL. And the denominator is the first order derivative of this production function with respect to K, or it's called MPK. And that is called MRTS, marginal rate of technical substitution, or the slope of the isoquant. So MPL, which is also denoted as FL, and MPL, the same thing, or this, they're all equal. Marginal product to capital is also could be denoted by F sub K, this term. Change in K over change in L is a slope of the isoquant, which is also known as the marginal rate of technical substitution between L and K. And this is our famous equation relationship, or the slope of the isoquant. Or you can rewrite it like this, the same thing, because this one is just the partial derivative of the production function with respect to L. And this term is the partial derivative of the production function with respect to K, or MPK. Intuitively, the MRTS measures the amount of K that can be reduced when there is one more unit of L, right? And that's why it's called marginal rate of technical substitution, like how much you can substitute, K with one more unit of L. So if you reduce this K, it could be substituted with one more unit of L, right, in order to keep the same level of output. So like you can say that this could be something like, if we go back to this example in the not this one. If we go back to the example of section 1, let me go back to this, right? So for this one, you recall this, so you can see that either this bundle of L and K, or this bundle of L and K, right? Or this bundle of L and K. You can see that it's on the same isoquant. So you can have this, you can employ 1 unit of L and 12 units of K, or 2 units of L and 6 units of K, or 3 units of L and 4 units of K. And still you can get the same amount of output, which is 2 times the square root of 3, right? So this is the, so basically, if you want to compute the MRTS to see, you can look at the change in K over the change in L, right? So from this point to that point, from here to here, right? The slope would be okay. From here to here, I can see that K decreases by 6 units and L increases by 1 unit. So the MRTS would be -6 divided by 1, which is equal to -6, right? But if you look at from MRTS between this and that, between these 2 bundles of input, so we have from here to here, you can see that MRTS actually changes, because now from here, change in K would be -1, change in L would be +1. So MRTS would be -1 divided by +1, which is equal to 1. Right, so this is going to be MRTS at that particular point. Now, or you can clearly see that the slope of the indifference isoquant actually is not constant. It becomes flatter and flatter as you move along the increase in L. Okay. And that is how we interpret the marginal rate of technical substitution, which is to measure the amount of K that can be reduced when there is one more unit of L. Let's say that if MRTS equal to -5, what does it mean? It means that, right, you need to reduce 5 units of capital and increase 1 unit of labor. Like to compensate the reduction in the capital input, you have to increase 1 unit of labor input, and you still can achieve, can produce the same level of output as before. So that is the interpretation of the MRTS. Next, if more inputs yield more output, right, then both MPL and MPK are positive, right? MPL and MPK, remember? MPL is the derivative of this production function with respect to L, right? So if MPL is positive, that means that when L increases, output would increase, holding K constant. And MPK are positive. That means when K increases, holding L constant, the output would increase, right? So that is a increasing function. This production function is an increasing function in both L and K, and that results into the positive MPL and MPK. And because of that, the MRTS would be negative, right? Because MRTS is negative MPL over MPK. So if this one is positive and this one is positive, then MRTS must be negative. And when we have negative MRTS, that implies that the isoquant must be downward sloping because of a negative slope or negative MRTS. And this indicates the substitution. When the amount of L increases, to maintain the same amount of output level, the amount of K has to fall. But since economists are quite bad at dealing with negative numbers, so some economists and some textbooks may define MRTS without the negative sign. So with that definition, the slope of isoquant is the negative of MRTS. So it's just some remarks that you maybe, if you read the textbooks that might define MRTS in a slightly different way without the negative side. But just remember that whatever is it have a positive or negative side or not, but you need to know that MRTS is just the indicators of the substitutability between the two inputs L and K. So if you increase one input, you must decrease the other input. And that's what it is. So far, everything looks like the consumer theory. So frankly, just copy and paste my lecture slides, replacing indifference curve, besides so on and so on. But now we reach the first point when something is different. And this is due to the fact that the quantity of output actually has the meaning, while the utility numbers does not. Remember, this is cardinal, but this one is just ordinal. In consumer theory, I told you that we don't consider marginal utility because marginal utility is meaningless. Now I'm going to tell you that we, however, do consider the marginal product because the increment in output is meaningful, right?